Okay, now that we have mastered solving one-step equations, we're going to be solving two-step equations. And if you're still feeling a little bit uncertain, don't stress. Two-step equations basically just have one more big idea, and then we'll actually get a lot more practice with getting those one-step equations as well. Okay, so here we are in question 25 with some video notes. Now, we are still using inverse operations to solve two-step equations. Okay, not too much has changed. And the thing is we're actually going to have to use inverse operations twice in each equation, because in this case there's two operations that are happening to x, so we're going to have to undo two operations. Now, here's the key. The order matters. We can't just undo the operations in whatever order. Okay, just like the same way we can't do when we did order of operations, right? We can't just do our operations in any order. And since this time we're taking operations and we're undoing them, we actually use the reverse of order of operations, right? We learned about order of operations. Now we're going to be undoing operations, so we're going to be going in the reverse order of operations. So if you remember, when we talked about order of operations, we kind of had 4 steps, and the first one was grouping symbols. But now grouping symbols is going to be the last thing we undo. If we have grouping symbols in an equation, we can't really break into those grouping symbols until we have them by itself. We're not going to see exponents in equations for a while. Okay, but that would be next. And then here, right, multiplication and division was next. And addition and subtraction was last. So if you notice, I wrote this in reverse order because, because when we are working with solving equations, we actually go backwards order of operations. So when we're solving equations, we're going to deal with addition and subtraction first. We're going to undo addition and subtraction first. Then we're going to undo multiplication and division. Okay? Then exponents, then grouping symbols. And we really only get into this kind of issue at the end of this assignment when we start to see the top of a fraction behaves kind of like a grouping symbol. Let's take a look at some examples. 3x minus 7 equals 8. Okay, so we're asking ourselves the same question as before. What's happening to this x? Well, right now this x is being multiplied by 3, and then 7 is being subtracted, right? Like if I had a number here, like let's say instead of an x here, there was like a number and it was a 5, right, or whatever it was. We would multiply first and then we'd subtract. Okay, that's order of operations. But since we're undoing operations, we're actually going to go in the opposite order, right? So we're going to actually undo this subtraction first, and then we're going to divide to undo this multiplication. Okay, now watch what I'm going to do first. I'm going to draw my line here. Why? Because, look, like I said, I'm going to undo this subtraction first. So watch, when I do it, right, this is subtraction, this is minus 7, so I'm doing the opposite, plus 7. Do I add 7 over here? No, absolutely not. I have to do the same thing on both sides of that equal sign. So if I already put plus 7 on this left side, I need to put plus 7 on this right side of the line as well. So what happens? This minus 7 plus 7, that equals 0. Okay, that's gone. 3x equals 8 plus 7 is 15. Use your fingers, okay, if you need to, right? Just 8, 7, and then 9, 10, 11, 12, 13, 14, 15, right? This is 3 times x. This is multiplication. How do I undo multiplication? I divide. I'm going to divide by 3. Same thing on the other side of my wall. I get x equals 15 divided by 3 is 5. Okay, let's do one more example. Okay, here we go. Here's my equal sign. I'm drawing a line. In this case, my x is on the right side of the equation. That's okay. No matter where it is, my goal is to get this x by itself. So I'm not even, look, over here, I didn't care about this 8. I could have even covered it. I'm trying to decide what do I need to do to get x by itself. So I had to get rid of the 7, I had to get rid of the 3. Over here, I need to get rid of the 9, and I need to get rid of the negative sign. It really doesn't matter what's over here. Okay, what matters is what I need to get rid of on the side with the x. So, just like before, I deal with addition and subtraction first. So here I have this plus 9, right? This looks like subtraction, but it's not subtraction. What is it? Do you remember? It's an invisible negative 1 being multiplied by x. So that is going to for sure come second. We're going to get rid of this plus 9 by doing minus 9. Okay, so I'm going to bring down, I'm just bringing this down, right? What's 4 minus 9? Okay, well, you might think to yourself, well, 9 minus 4, that's 5. But 4 minus 9, right, this time the 9 is bigger and I'm subtracting it. Okay, this is, I have 4 patches and there's 9 holes in my boat. Oh, that's 5 leftover holes. Okay, now this -1 is being multiplied by x. It's being multiplied, so I'm going to go ahead and divide by -1. Negative divided by negative is positive. 5 divided by 1 is 5. So x equals positive 5. And we can always check our answers, right? If I plug in here, this becomes negative, right, negative x. This becomes -5 plus 9. Does that equal 4? Yes, it does. If I plug in 5 here, 3 times 5 is 15 minus 7 equals 8. Yep, that looks good. Okay, so those are your examples. And let's go ahead and try this out. Number 26, number 27, and number 28.